A very good morning to all of you. I, Jean Salis, take an opportunity to welcome you to all this event organized by CMTI. CMTI is celebrating Ministry of Heavy Industries Week from 10 to 16 of January 2022 on the occasion of Azadi Ka Amrit Mahotsav, organizing several events under the various themes to mark the 75 glorious years of progressive India. As a part of this week-long celebration at CMTI, today we have organized a manufacturing training summit under the theme Results at 75. The focus of this event is to deliberate on the gaps in the skill sets of the engineering students, the role of the researchers, and the other stakeholders in imparting the required skill set. There will be an interaction section subsequent to the expert deliberations. I request all the participants to mark their presence throughout the event. Our Honorable Ministers, Dr. Mahendranath Pandey, Minister of Heavy Industries, and Shri Krishnapal Gurjar, Minister of State, Heavy Industries, have conveyed their message on this occasion. The message reads as follows. Azadi Ka Amrit Mahotsav is an initiative of the Government of India to celebrate and commemorate 75 years of progressive India and the glorious history of its people, culture, and achievements. As a part of this initiative, Ministry of Heavy Industries is celebrating Azadi Ka Amrit Mahotsava from 10 to 16 January 2022. Ministry of Heavy Industries is focused on developing a globally competitive, green and technology-driven manufacturing sector, including automotive and capital goods sector, which propel growth and job creation. To achieve this vision, the Ministry has launched a series of initiatives, including the faster adoption and manufacturing of electric vehicles, FAME scheme, National Programme on Advanced Chemistry Cell ACC Battery Storage, Production Linked Incentives PLI scheme for automobile and auto components, scheme for enhancement of competitiveness in the Indian capital goods sector, etc. As a part of this celebration of Azadi Ka Amrit Mahotsava, Ministry of Heavy Industries, in association with its CPSCs and autonomous bodies, has planned series of events and activities at over 40 locations across the country during the week of 10 to 16 January 2022, focusing on the themes of actions at 75, achievements at 75, ideas at 75, resolve at 75, and the freedom struggle in areas of innovation, manufacturing excellence, Atmanirbhar Bharat, environment and sustainability, Swachh Bharat, Swasth Bharat, unsung heroes of freedom struggle, etc. The event include inaugurations, new product launches, technology demonstration, technical exhibitions, seminars, webinars, expert lectures, yoga and meditation sessions, health camps, cultural programs, cleanliness drives, and the competitions amongst children on freedom struggle and movements, etc. It has been emphasized to all the units of ministry to follow whole of the government approach and ensure people's participation, that is Jana Bhagidari, in the events and activities in the week-long celebrations. Directions have also been issued to ensure COVID-19 social distancing and hygiene protocols during the events and activities. We urge everyone to participate in the planned celebration of Ministry of Heavy Industries from 10 to 16 January 2022 under Azadi Ka Amrit Mahotsava. Dr. Mahendranath Pandey, Minister of Heavy Industries, Shri Krishnapal Gurjar, Minister of State Heavy Industries. I request our beloved Director, Dr. Naga Hanumayya, to start the event by his welcome remarks.
Good morning, respected expert speakers, principals and deans joined this occasion, and the students and my CMTI colleagues. As I already mentioned, this is a third day event. The first day, 10th January, we had an event primarily focused on demonstrating the technologies which are developed in India beyond the lab scale. There were 21 such speakers presented. Yesterday we had a CMTI MSME Connect where the MSME, local MSME joined, and we exchanged ideas and also launched 2 products designed and developed by CMTI. But today is a special day. That is, we are going to address very important aspect in the manufacturing value chain. And also special, it is, today is a National Youth Day. So we are going to talk empowering the youths, that is through skilling, reskilling. If you look at this HR in manufacturing, I believe HR is the only element which can build the system or kill the system, no matter what facility, what technology we have, or what money we have. So now we have an expert. I think it is very rare opportunity to have experts like this. Two leading experts from academia, Professor B. Ravi from IIT Bombay and Professor Amrit Chakravarti from IASC. And we have two leading industrial experts, Shri Kaustubh Shukla from Godrej and Ms. Mohini Kelkar, who built the company from garage to international company, that too in the machine tool area. And we have the researcher, now is an industrial professional, that is Ram Gopal. After spending 3 decades in CSIR research institutes, now he holds the senior position in the MSME industry. And last but not the least, Chandramouli, he worked on several MNC setup, organized structure setup, and he is actively involved in several government initiatives, particularly for the Skill Council. I think this interactions is going to have meaningful for the benefit of Indian youth. And it is also important to CMTI because CMTI training is one of the vertical. So we are also looking this outcome, and also if it is required, we wanted to take this deliberation further. So that would help CMTI to decide or fine tune our training programs, because CMTI offers 55 training programs annually. I think that this will also help us to relook into our training programs. Just to give little background, what I understood in the industry, I think HR development is the collective responsibility of 4 elements. One is individuals, he or herself, let us call it as an employee or the student. Second is an employer. Third one is the academic institutes who produce this HR. The fourth one is the government who facilitate this ecosystem. Although there are some exceptionals, I will more or less the common issues related to this is, if I quote the report published in 2016 by Times of India, only 7% of the engineers are employable in their core sector. So it clearly indicates, so the graduate engineers passing out from college lacks in the desired skill sets. The second aspect is 15 lakhs engineers are produced, the job creation is 5 lakhs. So naturally, when I passed out from an engineering college as an individual, we know no matter how rich or have money, but majority cases, these students studied their engineering by taking bank loan. So our parents are also expected that their kids after graduation, they have to take up the job. So now it is not that I've taken up a job because I liked it, because I taken up the job because I wanted or I want to survive. So there are limited options before the individual to take up these jobs. Second is, if you look at an employer's perspective, India is MSME based. So MSME is not well equipped, both in facility as well as on financial resources available to them. They are not able to spend to train the manpower. They are always look at the manpower which are ready to do the job the day they report. And the large sector, in earlier days, there was a concept of apprentice scheme, and also they were taking graduate engineers. But these kind of things are not kind of MSME cannot afford. So naturally, they are looking for somebody who is otherwise skilled, and he will start delivering the day he joined the company. And if you look at the research establishment like us, so though we have to deliver the projects, and we also train some of the manpower. Always training is again, it is a neglected here because it is not my job. That is what my research colleagues look at. Because he has to deliver the project, all projects will have an ready class. So definitely we are always looking for a ready people. And the larger industry, yes, they can able to do it, but at the same time, so there are huge options before them. So naturally, they always pick who meets their skill sets. Then, if you look at academic establishment, the challenges is particularly type 2, type 3 institutes. Teaching faculty is an issue. So many of the teaching faculty, yesterday he was a student and today is a faculty, because this is one discipline which doesn't require any training, proper training for a teaching, unlike like a B.Ed, we go for a school education, but here such requirements are not there. And there are many colleges, there is no question of specialization, because I usually say that the manufacturing course is taught by a faculty who otherwise never operated a lathe. This is the scenario of the many colleges. And even in the university system, universities have 300 plus colleges, though there are some few autonomous colleges, but the syllabus is mostly top-driven syllabus. And faculty, being a faculty has to complete the course curriculum because he teach, but the exam is conducted and paper is set by somebody who is unknown to the student as well as the faculty. So naturally, the focus is more on the percentage of passing rather than the skill set. And second is the practical-based learning that is grossly missing in engineering school. Although there are schemes like internships and all, so many of these internship schemes and all have become a business. So naturally, earning of 2 credits becomes the focus instead of what we learn or what is offered as a practical teaching. And these are all the challenges. If you look at a government, yes, government cannot support for all the resources, though there are few fellowships, schemes and all, but this is only applicable for the research training, but definitely is not there at the undergraduate level. So now problem is with respect to manufacturing. So many of the engineering colleges, particularly mechanical engineering departments, mechanical means including production and allied courses, they're not getting sufficient admissions. Even some of the colleges are winding up their programs because the job prospectus in the core sector is gradually reducing, or the benefits, the salaries, typically now engineers' salary starts from 10,000 to 12,000 rupees, and they are expected to work for 12 hours at least minimum. So naturally, the students are asking, why should I look for a core sector? So they're all look into different sectors. So there are specific challenges. So, but at the same time, yes, it is collective responsibility of all these 4 elements. I'm sure so our eminent experts would address some of the aspects during their deliberations. And the end, we have an interaction session. So we request all the audiences, particularly the academic faculties and the students, so kindly interact with an expert. And then depending on the takeaway from this session, so we also CMTI look at building our training programs, and then how CMTI could contribute to this national mission, because HR development is not any individual's responsibility, it is collective responsibility. So thank you very much. So thanks to all the eminent speakers for accepting our invitation and spending your valuable time with us. Thank you, sir.
Moving on, we have our eminent speakers who have joined us virtually. Now I take an opportunity to invite Professor B. Ravi, Institute Chair Professor, Department of Mechanical Engineering, IIT Bombay, to share his valuable thoughts. His research interests include metal casting, simulations, medical device innovations, smart manufacturing. Over to you, sir.
Yeah, good morning once again, everyone in the room, dignitaries, CMTI team, including Director Dr. Naga, and all participants, maybe students, teachers, hopefully, in the room. I think we are seeing this very beautiful exercise by the government to involve all the stakeholders, and we are seeing now stakeholders, academia, industry, end users, and so on. And some of us in the room have been participating in this a visioning exercise, which is for trying to imagine how India will be in 2047, which is 100 years of independence. And very beautifully, government came up with this even a name for this exercise and the period uh, to that 100 years celebration, which is next 25 years, right? So 22 minus and 2047 minus 2022, which is 25 years. So it's a 25 years of visioning and implementing, and of course, finally benefiting from the whole vision. So this exercise is underway as we speak in multiple ministries. Some of us have been fortunate to be a part of the deliberations. What I would like to share is that one word which is now we are seeing common across the deliberations, across the sectors, whether it's heavy industries or pharma, both of which happened this week, last week. We are seeing the word innovation as one common word which is everywhere, in every discussion. Okay. And innovation applied to manufacturing, which is today's context. And the role of teachers in that whole innovation ecosystem building is what I'll share in the next 10, 12 minutes or so. Naga, is it okay if I take 12 minutes? You want to keep it tight? I'll do it in 8 minutes, not an issue.
Yes, sir.
All right. So let me see if PPT comes up. So this is the title given to me was about these challenges, opportunities, and strategies for HR development, especially towards creating industry-ready engineers. And I'm going to introduce a word called reinvent as we go along. Let's see how it goes. So first of all, I want you to focus on the middle part of this slide, where we are seeing an increasing number of students, students from, let's say, high-end colleges, tier 1 colleges, they will gun for MNCs. And a small fraction of them now gunning for startups also. But if you look at tier 2, tier 3 colleges, they like to play safe. They look for PSUs to start with. If it doesn't work out, then they go for maybe medium, small, medium enterprises, right? But we are seeing a very rapid growth in the trajectory of many students opting not to join a job full time, but to do what is called as short-term consulting projects or gig work. Okay. And if you look at it from government's point of view, this is quite welcome because students becoming job creators for themselves and for others instead of job seekers is a music to everyone's ears. Okay. And even look at industry also, where many engineers in many companies are now replaced by, let's say, diploma or ITI engineers. Core engineers are very few, and they are the permanent ones maybe, but a large amount of work is being done by contract employees. So even industry is moving towards a short-term employment kind of a thing. And if you look at youth, and if you see them carefully, our own children and others, their friends, they are saying that we would like to learn something in a focused way, pick up a consulting job, earn for next few months, and then take a holiday, and during holiday learn something new maybe, and repeat the whole cycle. So, and you see many of them are not even wanting to take, let us say, buy a house. We say buy a house to our children. They say no, we want to just rent a house. The whole culture of the youth, the mindset is as we see, is changing very fast. And where are they going to learn the latest skills? Online learning. Do you really think teachers are relevant anymore? No, unless we reinvent ourselves. Instead of trying to take a content which is 10, 20 or 40 years old, especially in manufacturing, especially look at workshop practice, and just repeating the same thing which is no longer relevant, we have to become facilitators for the kind of knowledge that the youth actually want to do the kind of jobs that they actually want, which is anyway in line with what government and industry wants. That's my one-line message in this particular thing. If you look from industry point of view, Indian industry is what I worry about right now. We are actually, I don't want to say miss the boat, but we are struggling to meet either the quality standards of the Western MNCs, global MNCs, or the cost competitiveness of Eastern countries. Without naming them, you all know what I'm talking about. But when we talk to customers, and doesn't matter which sector, customers are not necessarily loyal to any particular customer, any particular vendor, unless it is a huge setup and they want to buy components from the same vendor. If it's a new product, they will look for anyone who is offering them better features and quality and price and so on. And at this point of time, fortunately, with the kind of developments which happened in the last 5-10 years, whether it's a 3D printing or AI/ML or virtual reality, And all these are, by the way, are information technology and different avatars. If you can somehow leverage these IT-based technologies to create customer-centric design and also married with world-class manufacturing, I think we have a great future ahead as a country. And I put sector in bracket there because it could be anything. It could be your capital goods sector, it could be medical devices, it could be automobile, anything else. Okay, you have to just put that sector also as one specialty. But other things, materials, design, manufacturing, management, quality, these are pretty much common in terms of overall competencies. And I just thought I'll share that why this is not happening, because if you look at this research, education, innovation, and business, and these are actually, it's a nice slide. I could take a little more time, but what I meant is knowledge creation is research, and those sectors are representing those axes. But the major issue is that we feel that these are done by different kinds of people. They are remaining in their own silos. They don't even talk to each other. They don't even attend the same meetings. And so this whole mindset, of wealth and knowledge not coexisting. I mean, this is to some extent in academic institutions still to some extent strong. If someone does too much of industry work or consultancy, they think, why is he not doing more of teaching, for example? And the promotions are driven by how much you teach and how much you research, not how much you actually make a difference in society. So it will take a lot more effort, and that's why Shakti in the middle here, before we can actually create ecosystem where we say everyone believes equally and contribute, saying that let us use knowledge to create wealth and let us use wealth to create new knowledge. But that ecosystem is still, I would say, we are in the starting journeys of the whole. And therefore, what happens is these ideas which come up in the research labs, and at the most someone builds a proof of concept and files a patent, it just dies there. No one really wants to test the product in the real life conditions and create a bill of materials, a process plan, a training plan, and even a factory layout. Which academic institute is doing these things? But unless we do that, industry cannot go forward and implement and replicate that. The word which I am now hearing from industry is that don't give us know-how only, also give us show how it is actually made in large numbers in scale-up thing. And so unless we have this technology accelerator, not just business accelerators, we are not to convert these research prototypes into commercially viable, marketable products. I think we are missing a lot of potential that is still in academics, but it is just dying there itself. And therefore, we are trying to create a process by which these ideas can go all the way to society. And we are saying to academics that don't be in the comfort of your lab or classroom or offices. Go see the real world, talk to the customers of any focus sector you pick up, look at know the world scenario, global scenario, technology scenario, define the problem in consultation with your end customers and other experts, and then only develop it. Otherwise, many researchers simply pick up what is hot in many other countries and start looking at that research. No, do your homework for what your region, what your country needs. Eventually, it can become a global product, but you start from a local need and eventually make a global product. Now, development part, everyone knows, and I'm talking about design, manufacturing, manufacturability, also cost also, and not just creating a high quality product. And that's where people stop. Please go one step ahead, create those quality management systems, do FMEA, do your pre-market lab testing as well as field trials or market trials, and create an ecosystem by which the manufacturing technology dossier can be licensed to the industry, not just a patent. Give them a whole file of every little detail that they need to just replicate the product and process. Once you do that, the rest of the thing is easier. Even industry is very welcoming, government is welcoming, funding bodies are welcoming to see that this replication and scale up can happen. But this 4D framework, what we call as define, develop, deliver, and deploy, where different roles, the key roles are being played by respective people in the brackets. Unless they all work together in seamless way, we don't see a great success stories. Now we have created the success stories. I'm not talking from top of my head. So this smart stethoscope, which was actually proposed by a rural doctor, who said, instead of sending the patients to city for a second opinion, can I send the sound of the patient's breathing or heartbeats? And therefore, this concept of a digital or a smart or remote stethoscope was brought up. And from prototype to product to now practice, more than 3,000 of these sold in the last 2-3 years. And this company is doing so very well, file patents in I think almost everywhere all over the world, and they're getting now orders from all over the country as well as global. This is a great exercise for us. But it should not be one-step success story or one-off success story. So we also create a pipeline, and that is where teachers have to worry about how to create a pipeline, which in our case starts from a hackathon. We pick up the best ideas and best people from hackathon, bring them to a very intensive training camp called MEDIC, and pick up the best ideas and people again and give them a 1-year fellowship to take it all the way into a prototype and then exhibition where they can show it to other stakeholders, and then cross the dotted line where you create a business startup, and then of course you can scale up with the help of other people. This pipeline is as important as the product or process of innovation. And using this, we have been able to now create a large number of success stories. In fact, every other month we are launching something or other. All these on the left side, which you see, are startup companies in red, and each one has raised a minimum average funding of 1 crore rupees. And on the right side, you see a lot of Indian SMEs coming forward and saying, we know the market and we can market the product, but we don't have the facilities to do R&D. Can you be our R&D house? So very beautiful partnership between academic industry. We don't do anything about specification of the product which they give. We just do the product development, testing, and a preliminary trials in the market, and hand over to them to finish the whole thing. And obviously, this kind of things now start creating success stories, get covered in the press. This is no longer IIT Bombay initiative only. It is now, we have spread it to about 20 institutions, mostly in Maharashtra, but many people are coming from as far as Guwahati and Kanchi to Jodhpur to saying, what did you do? How did you do that? And can we create similar ecosystems in our institutions? So that brings me to the stakeholders, which is that apart from the triple helix that all of us know about, the end users, in this case hospitals, are very important, doing their respective jobs. But also we are now recognizing the importance of these other 4 stakeholders, which is technology accelerators, business incubators, testing centers for technology products, very critical. We still don't have too much of those facilities in the country. Investors, all of us know, but believe me, media's role is as important as anyone else in this whole set here. We have to make friends with the journalists. So when journalist comes and says that we want to cover your story, I say you come and spend some time in the lab, watch what is happening, talk to those innovators, test the products yourself. You have to make friends in media to kind of create this whole ecosystem of innovation entrepreneurship. Okay, so to summarize in one slide, in my humble learning, what I found is that 4 critical pillars of this innovation ecosystem, which you must create in academic institutions and train the academics so that they can tomorrow create job creators instead of job seekers. One is the team structure. It has to have interdisciplinary people, and just not engineers. You also get a soldier, you also get a tailor, you also get grandmother. I mean, it has to be across the society. And mentors, I cannot overemphasize enough. You need people who have already done it, been there, to hold the hands of these youngsters. Other things are simple. And when you talk about innovation, you've got to be able to take risks. You can't take risks unless you are overcoming your comfort zones. You have to go out of your way and be prepared for failures. But risk means failure, and failure means you'll also be able to prepare to get up and then learn from that and go forward. We have to be able to fail multiple times in our life. My generation, we were able to fail only once or twice because it would take 10 years to do something. But now it's possible to fail within 1 year and learn from that and move forward and do something else. Tweak the formula, tweak the process, and go forward. Infrastructure is there in some places, but what I would like to focus in detail is your pilot batch manufacturing is not there. Industry is geared for mass production, and academics are geared for only prototyping, 3D printing 1 piece, 2 piece. Who is going to make 10, 20, 50 pieces which are necessary for market research and field trials? Okay, that has to be put into place. Very few places in the country can do that at a reasonable cost. And finally, academics do not talk about total quality management and ISO 9000 and all that. Can you believe we actually have an ISO 9000 for our lab? People don't believe it. We're an academic lab. Why are you doing that? But best practices capturing in forms and records so that you can very quickly train a new person. That person becomes plug and play, And when you go to government or industry or anyone else, they just look at your forms, signed forms. They're so happy to collaborate because everything is already there. Everything is done scientifically and certified to be like that. Now you may ask, this whole thing looks very, very crazy to do in academic system. This is our industrial kind of stuff, right? And many people get scared when I show this slide saying, how can you even think about doing that? I tell them simply one thing. You think about the end user that you want to help. In our case, the example which I showed, medical domain, I say that you think about the poorest patient in the remotest area that you have met. We go to a lot of those rural health camps, for example. I say you think about that patient, think about that patient's picture in your mind or on your workstation window, and say you're working for that person. Okay, and then of course you're working for the country or the region or your institution or your lab, and for yourself at the very end. Okay? If you keep that end user in the mind, especially unprivileged people, somehow magic happens, and we have seen that happening multiple times. Somehow ideas will come, somehow resources will come, somehow people will come, even funding will come, and things do get kick-started by themselves. Now, also last, I want to share that it needs a different kind of people to put the whole thing together. We are talking about a different kind of freedom fighters. That was a political freedom. Now we're talking about economic freedom and maybe freedom to have a good life, right? So you need people who love doing what they're doing, and the measure of love is cheerful. You forget about food and sleep if you are really doing what you love to do. And also what you're good at doing, which is your degrees and experience, that gives you confidence, what you can be paid for, and what the world needs. And again, if you intersect the four, what you love to do and what you're good at doing is what is called as passion. What you're good at doing and what can be paid for is, of course, profession. But if the same doctor teaches biology to the street kids in the building, that is vocation. Some money can be still, honorarium can be paid. But what the world needs and what you love to do is actually called mission. What we need to get is people who connect the four sides, and they have found what they want to do in life. Okay? Or if you want to find something what you want to do in life, you ask these hard questions to yourself. Okay, and once you find a mission or what you want to do in life, you find people who connect the four sides of the whole thing. Then you slowly start building the team which can make a difference. The team doesn't have to be in hundreds. It could be just 4 people, and you can go forward into it. So this is my last slide. So basically what I try to summarize is we have to go beyond research, go beyond education, go beyond innovation, and go all the way to entrepreneurship for social impact, economic value addition. And of course, we all want to retire or die in a country which is not only very economically developed, but also, of course, sustainable, environmentally, and of course, all of us need to be happy and healthy about the whole thing. I hope some ideas are delivered in these slides and what I said, but I would love to hear from other speakers and everyone else in the room. What do you think about it? Is it possible to do that? Am I wrong in some way? Is there something which the thinking has to be improved? We all are collectively on the same side of the table as far as India 2047 is concerned. Thank you very much.
Thank you, sir, for emphasizing on the bridge between the academia and industry, innovation process, that is 4Ds, define, develop, deliver, and deploy, innovation ecosystem, and success story. Thank you, sir. Moving through the event, I request Professor Amaresh Chakrabarti, Professor and Chairman, Center for Product Design and Manufacturing, IISc, to deliver his talk. His areas of interest include design synthesis and creativity, eco-design, sustainability, artificial intelligence and data analytics, product informatics, smart manufacturing, biomedical devices, sensors and actuators. Over to you, sir.
Hello, good morning. It's good to see dear friends and colleagues, Ravi, Sri Chandrapuli, and of course Naga Hanumaya, and everyone else. So a very good morning, and as usual, Ravi has already played an innings, started with gems, so I come second after his innings, so it's always going to be a second act. So let me share some slides just like Ravi did. And some of the, I think we are both very aligned with each other. So there are many things that Ravi has already said that I don't need to repeat. But if I do repeat, that is only to re-emphasize that point. Okay. So rather than giving that background, which is pretty much set by him, I am going to talk about 3 or 4 different initiatives that we have been taking at University of Science that not only resonates with some of the points that Ravi has already mentioned, but also perhaps in some areas expands it a little bit that one might be looking at or expanding on going forward. So in fact, what I'm going to do is largely I'm going to talk about 4 sort of training education activities that we are doing at IISc that tries to embrace more than traditional education. All right, so I'm going to talk a little bit about the importance of, and I'm going to focus on design and manufacturing, particularly that is contextual, given the emphasis that CMTI has and the whole country has. And I'm going to start straight away with some of the things that our students are doing, because that then enthuses you to perhaps listen to the rest of the talk. At the end of the day, why is it that you would listen to a proposal if the proposal hasn't borne fruit, right? So here is an example, Sql Innovations. It's an innovation startup that started from a master's project that Nitin Gupta and Nikhil Meshram took at CPDM, my department, in order to improve the cotton harvesting productivity. Without getting into the detail, they actually got a very interesting result. So they incubated, and then they started their own company, which has more lately, and I haven't revised the slides, got some of the business excellence awards and so on from agriculture. But most importantly, they have been employing people and they have been expanding. And they are not just supporting cotton harvesting productivity. In fact, they are not doing that at all. They have expanded that into harvesting in general, and they are utilizing many of these tools that Professor Ravi has talked about, IoT and so on, in order to enhance the capability of their products and systems. This is another example, Purak. It's an affordable advanced prosthetic arm that uses only a single actuator in order to operate what is called an under constraint manner a prosthetic arm for the lower arm. And this was again developed as part of a master's project. Vinay, Nilesh are the students, and Professor Divakar was the supervisor. And this was sufficiently interesting that Wellcome Trust, a global funding body, then came and said, we would like you to collaborate with Oxford, because this is also important, not just in India, but around the world, including the UK. And very interesting collaboration took place. This led to a company called Grass Bionics that they started, and it's already, the product is already in the market. So that's another example. This is Gayatri Award. There are many. This is another thing. It's an affordable insulin pump for children from Dr. Manish Arora's group that Deval and Rohit worked on. And this is Lexus Design Award for a robot that cleans sewage. This is Milka, the most innovative low-cost innovation award that Puneet got for his low-cost innovation that went and impacted a small micro enterprise. And this is the James Dyson Award, the latest that Deval got for the live box for affordable transfer of live organs. This is this country's winner for this prestigious award. Now, what is it that all these awards are telling? I mean, you can get lots of awards, but it may not impact. I mean, there are 3 or 4 points. One is that, these are all socially important problems. Second is that the education is not limited to doing a project, writing a thesis, and getting it to gather dust, but going out and, as Professor Ravi has already emphasized, making a difference in the society. And that's exactly what our vision is. How do we pursue excellence in the areas of design and manufacturing, so that we can support innovation of systemically complex, technologically intensive, and socially impactful solutions by embracing the functional, but also the aesthetic, usable, and the sustainable, right? And one major issue that the country has is its inability to develop reliable, robust, working prototypes and solutions. So there is an emphasis on hardware prototypes. Not that software is unimportant, but it can come as an add-on to this. So talking about again developing professionals, creating leaders, innovating products and manufacturing systems, and developing knowledge. Again, pretty much around what Professor Ravi has already said. Now, I would like to just spend a little bit of time on the manufacturing aspect of it. Now, manufacturing is something that has expanded well beyond, cutting metals in grimy little rooms with very little light, right? So it is much about the entire manufacturing life cycle, which is centered around cutting metals, right? So how do we bring in technologies and reskill people and so on in order to support that? So there is a global resurgence of manufacturing, as we all know. Every country is investing in it. Now, what is it that we try to do? And again, I think Professor Ravi played a very significant role here in the early stages of envisaging the program, where he was spending time at National Institute of Advanced Studies. We had tremendous discussions at those days. Basically, manufacturing is focused on 4 points. One is that it must focus on the entire life cycle. Okay, product, production, services, and business. And second is it must be focused on innovation and not just doing something that somebody else does and doing it in a skilled manner. Okay, and therefore design becomes a central element. Third is on hands-on development. So you need to have interdisciplinary faculty, strong realization support. Okay, and the fourth is emphasis on new manufacturing technologies, digitalization, connectivity, and sustainability. So those are the 4 elements on which it is based. I'll skip. So again, something around what Professor Ravi has already said, developing knowledge, developing technology, developing people, and developing startups. And so how do we train people to do research, develop, translate, a school of practice that brings together all of these. Okay, and there is an MTech and there is a research program around that. The MTech program is to create future leaders in manufacturing around multidisciplinary courses, and this is about smart manufacturing. So you need to have components on both smart and manufacturing. So therefore, traditional courses on advanced materials manufacturing processes, but also digital design, HCI, systems, sensors, AI, supply chain, and so on. And then this is cooked together in hands-on skills and training in the facility, as well as industry and lab partnerships and projects. The teaching program, I'll skip that. I think this is not so important. The design is also, manufacturing and design are 2 parts of this ecosystem. So therefore, we already have a 25-year-old design program that focuses on product design and engineering. And again, the focus is on entire life cycle, focuses on innovation, focuses on hands-on, and the focus is on new technologies. So you see that there is not a great deal of difference, except for the fact that one is how to do design, and the other is how to create, innovate manufacturing systems and understand how they operate. Again, the thought is very simple. We're creating future leaders around multidisciplinary courses where you need to know how to design, so design methodology, creativity, but you also need to have the HCI, the materials, the supply chain, and so on, and then carry these through design, make, and test projects. About 1/3 of them get technology patents, and about 10 to 15% of them go out to do their own startups. Okay, so last couple of points that I want to make. One is that these are courses, as you have seen in the beginning, that they have gone on to actually create entrepreneurs and so on. So they are not simple academic courses. And this is something that we have started last year, where we are taking on to train people in industry, okay, professionals. So it's a PG advanced level certification program in digital manufacturing and smart factories that we have initiated with Talent Sprint as the platform. And right now, about 50 industry professionals with 15+ years of experience are getting trained in that in order to get a 360-degree view of all the technologies that are involved in Industry 4.0. And the last point that I want to mention is that we also have started an interaction where, again, Professor Ravi mentioned that how do you not simply give know-how, but also show how, right? So we have been taking on a competitive basis a number of companies, MSMEs, and we are training them to become innovators. Okay, so it is handled by students at CPDM, and they work together to solve a problem that is of interest, okay, of that particular company. So by the time this program is over, they get a solution, but also they get to know how to solve. And those are the 4 points. So let me summarize. One is, how do you train people to do design well, and particularly for difficult problems, and particularly using technologies, and particularly using technologies of the future. We should not shy away and say that we have always have to solve problems using jugaad. Okay, it's important to continuously look at the forefront of technology, because these are the ones that will give you much greater leverage. They are high risk, high gain, the possibilities. Second is that how do we train our people to become future leaders of manufacturing? Third is how do we train or retrain our existing leaders in industry to top up their skills? And fourth is how do we train our MSMEs to become better at doing not just getting a solution, but also becoming good at doing innovation on their own. So those are the 4 points perhaps that may be worth considering. And I'd like to thank all of you for listening to me. Thank you.
Thank you, sir, for sharing your thoughts on manufacturing initiatives, design, and finally various courses on digital manufacturing and smart factories. Thank you, sir. Our next speaker is Sri Kaustubh Shukla, advisor at Godrej and Boyce Manufacturing Cooperative Limited. He was heading the industrial products division at Godrej, capacity of Chief Operating Officer. IPD is the consortium of 4 divisions consisting of process equipment serving oil and gas, petrochemical, power and fertilizers, tooling serving automobiles, railways and consumers, durables, aerospace, space aviations and defense, precision engineering, nuclear power and naval system for defense, wind and steel. I kindly request you to address the gathering.
Thank you, CM, Dr. Naga Hanumaya, and for this invitation to participate, and a warm welcome and good morning to all my co-panelists, and to the audience. I think I'm sort of recapitulating what Dr. Ravi and Dr. Chakravarti mentioned. It was so good to listen to them that engineering colleges are actually stepping up, and here is a very, very strong evidence of how they are stepping up into applied technology, applying innovation, and not only that, they are actually incubating startups and future wealth creators. So amazing sort of presentation. I will take a step back and go to the problem that Dr. Naga Hanumaya presented earlier. He mentioned a couple of things that the manufacturing industry today is not getting the quality and quantity of engineers it needs. At the same time, there are engineering colleges where probably people are not choosing mechanical or production engineering, and manufacturing is not seen as a great career opportunity. And coming from manufacturing field, I thought it's important to dispel all those misgivings, and therefore also try and suggest a good way out. So with these few words, let me start my presentation. I'll share my presentation. One of the panelists can confirm if they're able to see that. So I actually already recapitulated the challenges, but I think it would suit us to know what are the actual challenges. Is it that the new entrants which are choosing engineering because they like it, or they choose engineering because they see it as a ticket for employment? I think it's very important, because over the period of time, if you end up doing what you don't like, then you don't pursue it with passion. And I think passion was something that both my earlier panelists also mentioned, and I think it's important we do that. We have to ask ourselves. I'm told that in the audience we also have institute chiefs and professors and all that. I think we have to ask, is the coaching and evaluation stringent enough that only those who make the minimum are allowed to go to the next semester or year? I think over the years, and this is my personal observation, I can stand corrected, I think we have ended up setting the acceptance bar low. And that's the reason why, I find that poor quality engineers can actually graduate from our colleges. I think from academia's point of view, irrespective of how one sees the passing percentage of our students, I think we should never let this, bar down, and the coaching and evaluation must be very, very strict. Another question I think we should also ask is, are we teaching them well enough to get them interested in the subject? Know why in addition to know what? Do we teach them to be prepared to solve real world problems? I think we saw both professors from IIT and ISC speak about it. These are, postgraduate courses. Shouldn't we be doing the similar things in our graduate, undergraduate programs? Is a question, because you have to get people interested or passionate about engineering. And what is the case really? The students that are coming out are not, is there unemployment or they are unemployable? I think there is a bit of both, of course. And, and then of those few people who pass, how many of the engineering students choose manufacturing? I think that's a very, another big question, because we in manufacturing, industries, we also find that there aren't any, good interested manufacturing graduates. And that brings me to the question, how well have you marketed the career in manufacturing to these people? And this is ironical because, we find that most of good graduates pursue a degree in management and are actually selling soaps and shampoos and, credit cards and what have you. Some of them actually become outstanding economists around the world. But, I think, so while engineers are doing a great marketing job, I think we as engineers are not doing good marketing job to engineers to get them excited about manufacturing. I think our dialogue must change. Our narrative must change. I think it's important to highlight to our students, and we have to do it early on. We have to important that, of course, the ITS provided a great boost to the economy, raised disposable incomes, with a trickle down effect, several other industries also kicked up. But if you were to look at, actually, if in Azadi ka Amrit Mahotsav, we are talking about, lifting the poorest of the poor out of their misery and giving them a good, sustainable, good quality of life and livelihood. How do we do that? Because today we find most of our population is actually engaged in agriculture. Of course, I mean, there are good aids for improving agricultural productivity, as we just heard, but it's also important that, I mean, we have to take into account that agriculture alone cannot provide the kind of jobs that so many people that will be relieved of, and therefore manufacturing must step in. There is absolutely no doubt about it. Do we discuss also stories around the world? For example, Singapore is a city state. Even water, drinking water, they import from Malaysia. But how many of us know that 25% of Singapore's GDP comes from manufacturing? Now, they have, of course, chosen appropriate manufacturing. They're probably doing high precision work. They're doing, integrated circuits and, aerospace parts or whatever. But the fact is 25% of Singapore's GDP comes from manufacturing. And for India, it has been hovering around, 14 to 16%, as bad as that. I mean, haven't we heard stories about Japan, a country which is so resource scarce? They import everything, and yet the best quality steel is produced in Japan or in Germany, maybe Sweden. I mean, so many the commercial buses plying on Indian roads are Swedish made. Now, so why is this happening? I mean, is it because, obviously we are not, promoting manufacturing well enough? In the engineering colleges, is the dialogue around Atmanirbhar Bharat? Do we tell the students as to what does this mean? What does Make in India mean? What is the intent? I mean, the whole idea is we have to be self-sufficient so that we need not have to import the things that we are doing today. To do that, we must manufacture them in India. To do that, we must become skilled. And, fortunately, all of this are underway. I think it's important that academia, industry, and the students must have conversations around, around this area. And I heard somebody mention about manufacturing, that today even do even people know as to what manufacturing is, or do they only know that probably it requires working in shifts, which by the way even ITS also, when you're working for all your global clients, you work in shifts. But dealing with unions, dealing with workmen, industrial relations, is that the impression that we are carrying of of the manufacturing? Do we speak about attractive career growth? Do we speak that manufacturing is extremely cerebral now? JIT, single piece flow, TQM, TPM, Kaizans, low cost automation, SMED, 5S, visual control, zero defect, Okayoke. I think all of this is extremely cerebral activity, and something that would really get engineers excited about working in manufacturing, provided we speak to them about it. How well have we spoken to them about the infusion of technology, automation, Industry 4.0? I mean, that's the current shop floors are extremely well kept, very comfortable, well lit, beautiful, safe workshops. Compliant workforce. I mean, I mentioned to you earlier about manufacturing means industrial relations. It's no more the case. You have compliant workforce, educated, well-to-do, progressive. So I think even at this level, because we don't know why people behave in the manner they do, is it that they carry wrong impressions about the manufacturing and hence they don't choose manufacturing, is something that for us to see. And then, if this has sort of aroused enough interest, I was wondering as to what therefore we could do to solve this problem. And first thing first, because I'm from the industry, I think industry, it's important that we engage with institutes. We should speak about our work, our challenges, the success stories, and we have to engage the younger generation. It's very important. And I mentioned to you because the moment I say this, some of my colleagues would say that, oh, we go and speak to them about our company during the pre-placement talks when we go to hire. It's too late. When we are speaking to them on the fourth year, that seventh semester or sixth semester, I think they have made up their minds. During PPT, all they're interested is your company working 5-day week, or what is the salary package they are getting. That is not the time to get them interested or enthusiastic about engineering. We must speak to them when they have joined engineering as to what wonderful things engineers can do. And therefore, the dialogue that I just mentioned should actually happen in the first year, first semester as they get. Industry must also facilitate project training, vocational training and short-term training. And, this is the time that, in the second year, as students walk into the industry, I think when they are given good quality projects, everything that has been said before about, the interesting part of engineering can actually be felt by them. I think, so the joy of being able to solve problems, to reduce waste, to improve productivity, improve efficiency can be very, very substantial. And of course, we have to engage with institutes to build curricula suited for industry. I just rattled few, acronyms earlier: JIT, LCA and TKM, TQM. Probably, I don't know the current syllabus. Probably all these things are not part of the syllabus. If they are, well and good. And even if they are already part of the syllabus, I think it's important that the industry engages to inform them that these are not soft kind of courses. These are very important, and how using these basic tools and techniques we have been able to solve problems. So I think we have to get them, the connection about the tools that they are taught and the problems that they are able to solve using these. And of course, participate in imparting such courses through the CSR way or whatever. From the academia, my request would be that we have to counsel the students about opportunity in manufacturing. I just mentioned to you earlier how direly India needs engineers in manufacturing, and how important, what is the focus the government is putting in for Atmanirbhar, for Make in India, for skilling India, and creating more manufacturing opportunities in India. And those cannot become successful unless engineers join. And therefore, from academia's point of view also, I think we have to start this dialogue and engagement early enough. Academia also must engage with industry in and around and exert to get the industry leaders to speak to the students. I think this exerting is important. Outplacement or placement department and coordinator, it's important, but I think more than getting the students placed in jobs, getting students interested in engineering would be a better thing to do. Because if they are interested in engineering, they can also turn out into entrepreneurs, as my earlier co-panelist spoke. And we have to get them excited about solving real world problems. I mentioned to you earlier about, are we sort of lowering the bar in coaching and evaluation? I think this is somewhere I'm sort of re-emphasizing that we have to critique their work. We have to get the best out of them. We have to get, sort of give feedback for asking them to improve. Unless that constant zeal that there is still better that I can do, unless that kind of rigor comes. And we have seen there are private institutes, training institutes, which take people from diploma colleges and they train into this. Rigor of training actually turns ordinary engineers into great engineers, and this is something that the academia should do. Of course, the industry will step forward to support them. And do participate with industry to reach relevant courses. And of course, professional bodies like us, CMTI, and so on and so forth, I think we have to sort of facilitate to make this happen. As I'm just recovering from COVID, so probably I'm finding it tough to speak, but I think I will end my presentation here. Of course, if there are suggestions, please feel to try and see if you like any idea, please suggest as to how we can improve it. And or once again, critique on my ideas are also welcome. I'll stop here. We can engage later.
Okay. Thank you, sir, for briefing us on importance of career in manufacturing, need for discussion on success stories around the world, industries and academia role in making engineering students industry ready. We are grateful to you for marking your presence with us today. We wish you speedy recovery. Thank you, sir. Moving on, we have today Srimati Mohini Kelkar, Managing Director, Grindmaster Missions Private Limited, India. Srimati Mohini Kelkar is one of the few early lady production engineers in India. After working in Perfect Machine Tools for a couple of years, she started her business of manufacturing machines in 1984 in a garage. Grindmaster is now a global technology leader in specialized turnkey machines for metal finishing, micro finishing, robotic machines, and abrasives, and also in providing total solutions for surface finishing requirements. I request you, ma'am, to share your thoughts.
Good morning, everybody, all my co-panelists and students and the engineering institutions who are present in this meeting. It is a pleasure and honor to share my views on this subject. My introduction is already given to you, but little bit about Grindmaster, my company, who from garage, we are a global company now. I wish to say this because this is a first generation entrepreneurs who have started in a garage and now we are a global company. So I think it is an example for every Indian student that this can be done. We are not indeed having a very, very exclusive, outstanding talent, but it is only the passion and the perseverance that has helped us reach this level. So Grindmaster today exports the machines of higher technology. It is not the mass machines, but niche technology machines worldwide, including Japan, Germany, and USA. We have also licensed our technology to USA, a company in USA, and this is a robotic fettling technology, which my son is spearheading. He is also an IIT graduate. He was supposed to talk on this forum, but he has gone for some customer meeting, so I'm trying to give you my inputs. So my first point, I have heard very nice presentations of my co-panelists, and indeed these are the issues. Industry wants the right manpower and we are not getting it. This is a fact. Now, looking at how others have done it, like in Germany or in Japan or even in China, how exactly they do it. To my mind, sandwich course is one of the solutions, and in fact, I have gone through a sandwich course of production engineering in Viability way back in 1980s. I'm a student of Viability production engineering, and it was a sandwich course. We had a vacation training after second year, a project after third year, say for 3 months. After second year, it was 1 month. It was just orientation. Even to go and work somewhere for 7 or 8 hours, and we should give that experience to the student. Uh, it opened up the mind. What is industry? What I am learning in engineering, how I can apply it. So as my previous speaker spoke, that this should happen well in advance when the student goes into the engineering career. I completely agree with that. A sandwich course enables all this. And in the final year, we had 6-month project, which was evaluated, and the project I did was in L&T. It was a fantastic experience for a young girl like me at the age of 19 or 20. I designed something which was implemented on the shop floor, and I'm told it is even used after 20, 25 years. So this is something which gives satisfaction, and that creates the interest in manufacturing. It is absolutely true that we need to refocus on manufacturing engineering. Sometimes the softer skills are taking precedence. Like many engineering colleges tend to get into the IT skills or software skills. Yes, they are required, but basic engineering is extremely important, and the basic engineering also should have manufacturing engineering as in the right perspective. For example, the production engineering course which I did, we had the machine tool design, we had the industrial engineering, we had how the industry works, and we used to have the industrial faculty coming to our institute to take a regular course. It is not like doing coming once and giving a talk. It was the industrial staff which came and taught us. All these things were done earlier. I really don't know why the sandwich course disappeared. So one of my strongest thing is, in fact, even commerce education should have a sandwich course, because finally a student should be exposed to what he is supposed to do after he passes out from engineering. This is one strong suggestion. Then another thing is about the course content. I don't know, but I heard that still Hazira Chaudhary and Chapman's are referred books, which we used once upon a time. So I'm also now more than 60 years old, and if we are using same books still, I think it is something which has to change. So maybe industrial leaders or experts in this area should take a lead and write the books which are relevant for today's time. But more than that, for example, CNCs, VMCs, all these machine technologies are available in India, and a course can be rewritten to include the advanced technologies in that. Not only this, manufacturing engineering should take a more prominence, and automation, as my previous speaker also said, because every industry, be it pharmaceutical or be it packaging, anything, everywhere automation is required, including the farm, you know. So the study of automation becomes very important. The elements of automation, the basic knowledge of automation should be given to every student. So rewriting the curriculum in these terms is, my another suggestion. In terms of engagement of industry, another thing besides the sandwich course wherein you put the students and even the professors into the industry, we have experimented this in Grindmaster. We had professors from Nagpur, but this was, like we personally knew that institute and they asked us what can we do, and so we said send your professors to our factory, let them learn along with the students, let them know what needs to be taught. So involving the teaching staff also in the industry, give them 6 months in a 2 year span, give them 6 month exposure in the industry. They can also do the industrial projects along with the student team. So this more getting closer is important, and I feel the industry is the shop floor, like Gemba. In our industrial terms, it is Gemba. Gemba means you be where the things happen. Don't sit in the offices and do the improvement on the shop floor. This is what we do in the industry. Same thing holds good for the engineering institutions. Go where the action is happening. So go where actually the things are happening, where you are supposed to work. Get that knowledge completely and solve the problems. As my previous speaker said, when you solve a problem, the kind of satisfaction you get is really good, and that is something which motivates a person. So industry has a number of problems, but if you tell them ki you tell us a problem in the institute, we will do R&D and come back to you, I don't think frankly it is the right way, and we are all going in that direction, unfortunately. Let me be very frank, because I have been talking about this for almost more than 5-6 years now, but little action is being seen. If you want really action to happen, this Gemba is very important. Industry giving institution problems and they solving in their laboratories does not help. We have tried even the R&D projects with IITs. Let me not say more details, but it has become a lab model. It cannot be commercialized. We are not interested in coming out with research which will remain at the lab level. If you want the research to get commercialized and get a commercial impact, industry has to give an angle of design of a concept at the lab level is very different. This is what institution develops, but if it cannot be productionized, if it cannot be commercialized, this remains a bookish research or a lab research. Nothing wrong in it. It has its own place. But if you want a multiplying effect, if you want our country to be Make in India, Atmanirbhar, etc., we need to put it in action. And that can be done only by very close joint working. I have observed that the institutions are on their own planets. They do not want to come out and understand what it means to commercialize the concept, They are not willing to even, properly listen to it. That if you want to commercialize this is required. You have to go in the field. You have to understand how a customer is going to use it, etc. All these willingness of doing all this will happen only when they go to the industry. They go and try to commercialize it. In Germany, there are institutes like Fraunhofer who do the bridging of this gap. They add the commercial angle to the R&D, which can be translated into the products which can be physically be used. So something like that, but it will be difficult to have an institute like this. So my point is, why not our engineering institute themselves come out and go more to the industry and give this angle of making a product commercially viable or manufacturable, not keeping it a lab kind of model. So with this, I end my talk, and indeed a pleasure to share my views once again with the August gathering here. I will be open for any question and answers. I will remain in the on the web call till the question answers are over. Thank you so much.
Thank you, ma'am, sharing your success story of Grindmaster with us, and also giving the importance of basic engineering, sandwich course, and automation. I would like to quote on Gemba, "Go where it's happening." Actually, I'm sure that it will inspire many. Thank you, ma'am. Now, I would like to call upon our next speaker, Dr. Ram Gopal V. Sarpeka, Senior Vice President, SPDT and IR Optics and Allied Engineering Private Limited, Bengaluru, to render his talk.
Good morning to everybody. I hope I am audible. Okay.
Yes, sir.
Yes. Yeah. I was going through and listening to the speakers before me, and very knowledgeable, very practical solutions as well as new solutions, novel solutions. I come from a research background of a Government of India lab, like Dr. Naga Hanmaya has come. Thing is that I just came into the private industry 6.5 years ago after my superannuation. I have to say something that whatever I had to practice, learn, practice, adopt, accept, and do in R&D lab, most of those practices were to be unlearned once I come to a private industry. And also, I'm not talking of an MNC here. I'm talking of a mom and pop based industry, a family-owned basis industry where the constraints are huge in terms of first and foremost is resources. Monetary resources, and comes the intellectual resources. And can I have that presentation? I have just one slide presentation. Can it be? I sent it to your people, Dr. NH. Yes.
Yes, sir. We'll do it.
Yeah. Good. Okay. Before while that happens, while that happens, let me continue.
Presentation.
Yeah. So the aspects, the points of discussion, points of concern are all same everywhere. What are the advantages, what are the threats, and what are the positives that we can right away see, the low-hanging fruits as well as the problems that we already know and are going to face. Those are the few items that I have listed in my presentation. It is there already? No, I can't see that.
So, sir, is it possible to share from your side?
How do I share that? Okay. Anyway, let me just start talking because there aren't many. So, the first thing is that education, engineering education opportunities in our country. In the opening remarks, Dr. Naga mentioned that 15 lakhs engineering graduates are coming out of the colleges in the country. 15 lakhs is a huge number. And how many are, one of the speakers have mentioned, employable and employment both. Are they, how many of them are really employable? What is the knowledge, and what is the, are they just coming out of the college with some information about engineering, or are they coming with the knowledge about engineering? This is a major question that we need to ask ourselves. And then comes the, when I say opportunities, means practically every child in every family is going towards engineering only, unless he or she is going very strongly towards medicine and few arts, of course, very few, commerce, and let's say attorney, becoming an attorney or so. Majority of the children in our families and my friends' families and in the society are going towards only engineering. That's a great impetus that the country is going through, or maybe there is a big lure of going to USA or getting an H1B visa. I have no idea what's the big reason, big inspiration to get into engineering, but that's a very positive thing. To majority of the children are going towards engineering education, but that's a good thing. And obviously so many engineering colleges have opened, whether you consider them as good institutes or just an engineering school or engineering shop, I don't know, but opportunities are there. Now, added to that, the next thing is that government has relaxed the rules of opening a academic institute. So obviously this has been facilitated by government. And then there is a demographic advantage. 27% of the country's population of 140 crore are youth. That's, I mean, below 30. So that means there is enough market for these colleges to get students. That is an advantage. But at the same time, then the third point comes academic standards. Are we maintaining the desired standards? When I say standards, that includes many things. I'm not talking of whether the laboratories are neat and clean, spick and span. No, I'm not talking of that only. I'm talking of the non-tangible things in terms of whether the curricula is up to date, whether the teachers are getting are getting their information, their skills updated. Something called a continuing CME, like in medicine, they have continuing medical education. Are we doing that for the engineering faculty in the colleges or in the across the country? I know that there is a big institute, Government of India Institute, once again, TTTI, recently renamed as NITTER, Technical Teachers Training Institute, that I see only meant for the diploma courses in the country. But is it happening for the graduate and graduate and postgraduate courses? I have no idea. If that's happening, not adequately happening, let me say this. How many students are getting the education which is needed by the industry today? And the answer is a big, very pathetic answer we are getting. So that is one standard I'm looking at. Second standard is how many engineering colleges, whether in the private sector or in the government sector, are having their laboratories. I'm not talking of putting more money into that. How many colleges are getting that equipment which is needed for them to learn hands-on learning rather than just a theoretical learning or blackboard learning or classroom learning. Classroom learning is certainly not at all adequate, and this is something which I'm very concerned. One is teaching, and then comes the standard of the student as well. How many students are really, let me use a very harsh word here, eligible to become an engineer? Just simply going through a state entrance examination, whether it is Karnataka state or Andhra state exam, whatever it is. Different states have their own individual things. I'm not looking at JEE here. I'm talking of the second, third category of the engineering students who are getting into the course, but are they really have that material in them, have the zeal, have the passion, have the intellectual capital, intellectual resources in them to become an engineer? This is a big question, and I'm sorry, the answer would be a big no. And this is another standard I'm looking at. If I compare today's situation in terms of engineering education, say, let's say 50 years ago or 45 years ago, there were very few colleges. Probably most of the colleges were run only by the Government of India. But what was happening is the students who were going into the colleges were very few, as well as coming out also, majority of them were employable. Unlike today, when an engineering graduate, an electrical engineering graduate is going to work as a clerk somewhere, or maybe sometimes I have seen in private industries working for as low a salary as 12,000 rupees, 10,000 rupees, after putting up 4 years of going through a training of engineering education training of 4 years, and putting at least 6 to 7 lakhs of their father's money, parents' money. Is that what we are looking at? So that's another thing I'm looking at. Engineering, when I say academia standards, I'm not just simply talking about labs at all. And I'm not looking at the ecosystem. I'm talking about the whole entire ecosystem. The teachers, the students, the colleges, the administrators in the colleges, and most importantly, the course curricula which they are being taught. And then come the job opportunities. Here again, I see a very heavily lopsided placement scenario in the engineering colleges. Majority of the students, irrespective of whether they are at IIT or an NIT or a government engineering college or a private engineering college, a big group of engineering colleges, or maybe one or two type of engineering colleges, majority of them are looking at only one particular type of job in this country, which I don't need to say, which may lead him or her towards the H-1B visa in a big company in the USA. Is this engineering? Can we call this as an engineering education? If so, Where is my manufacturing engineering then? Job opportunities should not be limited towards only one particular type of job. So this is leading to one-dimensional or mono-dimensional jobs growth. People are not looking at actually going into a shop floor, touching their hands. It could be a chemical engineering, or it could be a textile engineering, or it could be practically a mechanical engineering. I am concerned about manufacturing engineering country because for the last 20 odd years, the whole engineering community, engineering student community, parents, engineering students, the parent community is pushing the people, pushing the students, pushing their children towards only one type of job, which we all know. I don't need to say it. So this is where the societal pressures come. Whether it is, I mean, when I talk to children in my own family, I'm now 67 years old. So obviously I have around 100 children in my friends' children, as friends' families, as well as my own family. When I look at these 100 children, 100 odd children, 70-80% of the children are into one area of work which I already mentioned. They are given a glamorous position compared to the other 2 or 3 20 odd children. Somebody is working in a workshop, or a mechanical workshop, or an electrical workshop. Acha, he is working only a mechanical workshop, whereas the other boy, oh, last month he went to USA. This kind of societal pressures are not right for the, not good for the country, neither for the society. So this is something which I really feel very sad about it. Now, what are the solutions? I have placed only the negatives in front of all of you. Now, then something which we all talked. I'm sure Dr. N.H. Naga must be thinking about academia, R&D lab, and industry interaction while we were at CSR labs. When you look at the advanced countries, particularly in USA, what was the big secret of their developed stage? Rather, India has been developing country for the last how many years? 70 years or 60 years? How long it will continue to be only the developing country, when we can say that India has arrived, India has developed? I want to see that particular thing in my lifetime. So for that to happen, particularly from an engineering point of view, I am sure this is true with any other discipline in the society. Academia needs to work very closely with an R&D lab towards industry. The reasons are very simple. When you have a concept, then having a concept doesn't mean that it is a commercial product. In between the concept and an idea to the commercially viable product, there are many hurdles which have been, I think, already mentioned by Professor Ravi in his first talk. Very beautifully has explained this. There are so many technology readiness levels, TRLs, we have to cross through. Are we going through doing anything in that direction? Not every engineering college may have the required infrastructure in terms of technological equipment, or fabrication equipment, or metrology equipment, or also the manpower, skilled manpower. It is time for them to tie up with a industry directly, or through an R&D lab with their industry. Because what is happening, in what is positives in all the three, academia has an excellent pool of students, committed students who want to make a career out of it. But what they do not have or may not have is necessary infrastructure, necessary skills. Particularly when I'm not talking of teaching skills here, I'm talking of workmanship skills, which are very much available in an industry. The second one, when you go to an R&D lab, you have an excellent idea, wonderful ideas, people working in their own projects. What they do not have, people to work down an intellectual nursery they may not have, like an academia have. That's something which they have to, that's the reason why they have to work together. And then come to the industry. Industry, we have real life problems, not some esoteric things. Today, after coming from a CSIR lab, a research lab, into an industry, I know what are the live problems that we are facing every day. If I work in an R&D lab and an academics institute, I may have a project of, let's say, 2.5 years, 2 years for duration. But here, my project is hardly 3 weeks. Within by 22nd day, I have to deliver the system to the customer. Here we are, unless we deliver the system in time, we will be ending with an LD class. Okay, late delivery class, 0.1% or 0.2%, depending on the vendor, depending on the ecosystem that we are working with. And unless we deliver it, we will not get the, in time, we don't deliver. Three things are very important for an industry: timely delivery, quality maintenance, and affordable cost, because most of the things, if we work with government, everything works under L1 basis, lowest cost, L2, L3, etc. If somebody has to go beyond L1 and pick up an L2, the government of India, the concerned organization have to give a big justification why we are going for an L2 class, right? So here industry doesn't have three things. One is intellectual capital. We may not have as much as say an IIT has, but if we talk to an IIT professor, his time is very valuable. So the cost that he may charge, the price that he may charge, we may not be able to pay it for him. So is there a passion-based contribution by them? We are yet to see that. Okay. So the point is, academia, R&D lab, industry, unless they work together towards a project, towards a technology, towards skill development, the concept of India becoming developed may not happen in the near future. This is something which I've been listening, saying, pleading. I'm sure Dr. Naga will agree with me, as well as the other speakers who have given their speech. That's where the role of the training institutes like CMTI come into play. I was asking many times this question to the faculty, the staff at the CMTA. Tell me, are you a teaching institute? Are you a research institute? Are you, what kind of, what is your mandate? They say, we do everything. I'm really surprised because they have so much of less manpower, but still they are attempting to do so many things. They are conducting, I think, nearly around few hundreds of training programs every year. But again, I was seeing that, a group of people doing a training program is not given the kind of respect they deserve in terms of the growth, the career growth, or the priority in the organization. This is something which I think the management at CMT is already looking at it, I'm sure. But the point is that they are doing a wonderful job, a very honorable job, because we need more CMTI type of institutes in this country where the skill sets are being imparted to the students. And also, here where I need to say one more thing. The engineering student, when he comes from from his academic institute, is he really employable? Most of the times the answer is no. To make him him or her employable, some training is needed, some awareness is needed, some orientation is needed. Who is going to do that? You expect the industry to do it? Most of the industries are willing to do, but who would bear the cost of the investment on this particular period of training? That's where CMTI type of institutes should play and are already playing a big major role. I want more such activities to come. The gap between learning and using it in a industry, in an R&D lab, has to be bridged very fast, very soon. That is something which very, very important, and that's not happening adequately in this country. So this is something which I have a big complaint on most of our engineering based institutes, whether it is academia or an R&D institute, that we are not talking to industry. We are not listening to industry. But frankly, we are not talking to each other. We are talking at each other. That we have to change. Nobody, people working like, Mr. Skalkar just now mentioned that we are like in our own planet. We are sitting in our own silos. This is not a healthy thing. Manufacturing does not happen this way. The thoughts, the ideas, the skills, the possibilities which as a professor or an academic member sitting at an institute at IIT or at NIT should come to us at industry, so that we can really fast. When the turnaround time in industry is very less, we can do it very fast and tell him, okay, this can be done, this cannot be done. If it can be done, at what cost it can be done? What is the commercial viability? So from TRL 1 to TRL 7 to take for an R&D, R&D lab, it takes a lot of time. I'm very sure because I worked there. At academia, I don't know whether they will go all the way up to TRL 7 or they will stop at TRL 4 or 5. But in industry, we have to be at TRL 7. Nothing else is suffice there. So this is something. And one more observation is, I visited Australia a few times and I saw there TAFE, training and further education. These kind of institutes are there, quite many, where skills are being imparted on a large batch-wise model. Like I'm talking of, say, a diploma or a sandwich course or maybe a polytechnics. I think we have to put our thoughts into that also, because if you have only engineer, unfortunately in the boom of engineering colleges, majority of the children who were going to a polytechnic have come to an engineering college. and they have neither developed the hands-on skills like a diploma holder used to do, nor the kind of theoretical and academic excellence in their engineering education. So they are falling between these tools. So we need to look at that model, TAFE model of Australia, where the benefits will be to the society. And then last point is global threats and future. Global threats, whatever we have seen in the last 20 odd years, where was China, let's say in 1995 or so? Where is it today? I'm not talking, I mean, let us discount this pandemic story for a couple of years, happening for a couple of years. How much progress the Koreas have made, how much progress Singapore has made, Thailand has made, Taiwan has made, China has made. Why we didn't do that? Now is the opportunity. If we don't cash on this, if we don't look at the opportunities that are coming our way, some other country, even Bangladesh, I've been told, Bangladesh is, I mean, has already pushed us far behind in terms of becoming a developed country. Manufacturing sector, they are doing a lot more. How come a tiny country like a Bangladesh has surpassed India in many of the parameters, the growth parameters, development parameters? What are we doing? What is that lacking in us? Are we not intellectually equipped? Are we not having enough infrastructure? Are we not having good students? Are we not having opportunities? Are we not having a necessity? What is not having? What we are not having? Maybe a collective thought process is not there, or maybe a political push is not there. Government, I think, is doing more than its bit. All these Atmanirbhar Bharat and other initiatives that have been started by government are exactly going in the same direction. But are we doing it in the real passion, real spirit, or are we doing for the sake of, in Hindi we say khana puri, just to say that okay, we also did it? No, it doesn't serve the purpose. We have to grab this opportunity, and now pandemic has given us a new perspective of life, perspective of manufacturing. Many times we thought that okay, we cannot run the factory when there is a lockdown, but over a period of time we developed our own systems, how to run the factory, how to run a lathe machine when most of the staff is at home. We have developed a few models, but we are not intellectually equipped that much at a small scale industry. This is where I think how to do a remote fabrication, or a precision fabrication particularly. I think this is another area. I'm sure some of the academic institutes are looking at this. Once these are taken care, I think the future of India is very bright, provided we take it into right spirit. Thank you so very much for the time and your attention. And I have to say this, the speakers who spoke before me have actually covered all these things which I mentioned, but most of my speech is need based and experience based for the last 7 years that I'm in the industry, preceded by a 33 years of my experience in an R&D lab. Thank you so very much. God bless you all.
Thank you, sir, for emphasizing on quality of education, academia standards, role of training institutes, a TFE model, that is training and further education. Thank you, sir. Now I request Dr. A.N. Chandramouli, Founder Director, Aerospace and Aviation Sector, Skill Council, to deliver his talk. Over to you, sir.
Okay, thank you, Dr. Harmantaya, and thank you all my co-panelists. Thank you, CMTI. Thank you, Ministry of Heavy Industries, Department of Heavy Industries. And it's a great pleasure, honor to be here today. Although I'm a last speaker, most of the good points already covered. I tried to add a little more value to this discussion today from a perspective which comes from my 4 decades of industrial career. I have not been an academician so far, but of late I contribute much to the academic world as well. Let me move on. It's always a challenge to come at the end. It's an advantage that I get more time perhaps, but eating into the question answer session is not fair for the 130 participants already raring to ask many questions. But I would like to cover some new thoughts today, which are a little refreshing to all of us, including my co-panelist. The emerging trends and drivers of the jobs and skills is my concern today, on which we are working very closely with CMTI and other organizations on the platform of the Samarth Udyog, what we call as the Industry 4.0 laboratories. But I'm not only looking at Industry 4.0 domain, But looking at the emerging job creation domains and sectors, I will illustrate with some examples. Please ring the bell when I exceed the time. I would also like to cover the emerging and future job roles and skills, which are little bit related to the sectors, but little bit away from that also. And I would also like to cover the multi-sectoral application requirements on the technical jobs, which seem to be the topic of the day. The engineers, which could be graduate engineers, postgraduate engineers, diploma holders, ITIs, bachelor of vocational engineers, and so on and so forth. And fourthly, multidisciplinary, what I call as a holistic approach of looking at the new job roles, which are very, very important. The current and the future is more important than the last 70 years of today's celebration. And finally, the multi-skill, which is a flexibility requirement of the modern manufacturing systems. My dear good friends, the skill and the flexibility is not only flexible machine tools and flexible manufacturing systems. The flexibility of the manpower, the HR aspect, which Dr. Hanumanthaya mentioned, is the most important. And of course, my good friend Ms. Mohini Kelkar already steal the thunder by talking about the experiential learning with the European model and also the Japanese model of the dual education, which I'll touch at the end a little bit. But Mrs. Mohini is a living example of that particular concept. Before that, let's sit back and relax, as they say in the aircraft, and think of where are the jobs, right? I think we are always worried about people running away to America. My predecessor spoke very beautifully that the single focused agenda is how to get the US visa or double the salary of the core functions through the very carefully mentioned single stream of jobs which he mentioned. But from that we have to move on to look at jobs in three domains: the industrial jobs, the research jobs, and the self-employment jobs, which otherwise we call as entrepreneurship. Ministry of Skill Development and Entrepreneurship, MSME, is a very important thing, looking at both employment and employing through the entrepreneurship. Let's move on from there to look at who are the job creators of the last decade. The aerospace industry today is grounded, quote unquote grounded, thanks to the COVID, which is now, this morning I heard 50% of Europe is already afflicted by the Omicron and other variants. The windmill industry is almost dead and gone. Solar is taking over. Finally, people have realized that the sun is the one which causes the wind also the waves in the ocean. So let's attack the original source, the sun, and then that is now catching up. The industrial, which is other than all other things. Before that, our famous automobile industry, the transport segment, which includes trucks, tractors, two-wheelers, three-wheelers, four-wheelers, earth movers and whatnot. The transport industry is still alive and kicking, thankfully, my dear friends, absorbing the several mechanical and other core engineers in this world. And the industrial being those who serve all other industries. I put them in the general engineering industry. These have been the job creators of the last 3 decades in the Indian developing nation. Who is going to be the job creators of the next 10 years in the Indian developing nation? Yeah, is the number one, advanced manufacturing systems, which includes additive manufacturing, robotics, and so on and so forth, of the industry 3.0 era. The second one is industrial automation, intelligent automation of the industry 4.0 era. The smart factory and the digital manufacturing domains, which is just burgeoning across the world thanks to COVID, exploding, and there are shortages. There are only 10 people in this country whom we could not find the particular placement. When my good friends in Coimbatore were asking, can you get me an IoT expert with 10 years experience? Sorry, sir, it is not available. The fourth is the data analytics, not only for business data analytics, but also for engineering data analytics across all the functions of the silos. The smart city and the smart infrastructure and the smart buildings, the smart factories, the smart skyscrapers, which is a big job creator which is exploding in this country and elsewhere. E-mobility, every other day a new company is starting an electrical car or an electrical scooter. So my dear good students, do not feel disgruntled or disappointed that these people are waiting to absorb you. There is a shortage in this industry, particularly for battery related functions. And healthcare exploding. It is not only the hospitals and the pharma industry, requires engineers as well. And medical equipment manufacturers is an extremely important area for engineers. And electronics and semiconductors, you heard recently, thousands of crores are being pumped into this country through FDI and other reasons. And some of our Chinese friends have lost out that investment. And Tata is taking the lead on this. And even Apple and Tata, I tied up with a very big industry in the Hosur area for manufacturing of the Apple phones. Electronics and semiconductor is going to be the way forward. We have lost the bus in the last 3 decades. Now is the time to catch up there. We need to look at how to train our people in this area. And last but not the least, already I mentioned about the energy sector, where it seemed to be, the wind seemed to be blowing towards the solar energy. My dear good friends, let us have our course curriculums tweaked towards the non-conventional energies in the near future. And the skilled students supply, my dear good academicians, should orient towards the job creation domains and not keep beating around the same bush called the IT industry, which our friends were a little shy to mention. Aspect I want to mention is advanced manufacturing skills cutting across all the sectors I mentioned. Cutting across all the sectors I mentioned is requiring core processes in manufacturing from design to after sales service. As I mentioned, design, development, machining, joining, assembly, inspection, maintenance, vendor engineering, logistics, after sales service. As long as there is a raw material being converted into finished product, these core functions are not going to disappear. Let us raise the salary levels, as one of my friends Ramnath wrote in the text box. Let us make a minimum 25,000 rupees minimum wages act for the engineers also. But the support processes will definitely absorb our graduate engineers. The core process will definitely absorb our diploma and ITIs and BWOCs. The support processes such as production engineering, manufacturing engineering, industrial engineering, project engineering, quality assurance, TQM, TPM, lean, etc., etc. All this will be absorbing the graduate engineers and the postgraduate engineers. Very sadly, we never project the industries are to be blamed. We never project when we go to the engineering colleges. These are the functions we need the graduate engineers with the intellectual capability, if not the hands-on capability. Let the hands-on capability remain with the diploma holders in IT. Nothing wrong. The Nehruvian era has conceived beautifully the hierarchy of these functions. And the last is industrial automation and smart manufacturing, which is where all the sectors are converging and all the functions are converging in the near future. It's already happening. There are 9,000 live jobs in Naukri.com and Indeed.com in the area of industrial automation. Please look for those jobs. I hope my slides are moving. Very important area where I'm working very closely with CMTI and other organizations are the Industry 4.0 technologies. But the application, yes sir, the application of these technologies, my dear friends, artificial intelligence and machine learning we are flogging the same horse again and again. But what about additive manufacturing? What about augmented reality? What about system integration, OT and IT integration? What about horizontal integration? What about vertical integration? Cloud-based applications, simulation solutions, Internet of Things, which is a backbone, industrial robotics, and last but not the least, big data analytics. Don't get scared with big data. Even small data analytics have come up now. And there are several other technologies, a conglomerate of all these technologies put in the basket of Industry 4.0. And very soon with human machine interface, Industry 5.0 and Industry 3.0 is still live and kicking in India. 3.0, 4.0, 5.0 can definitely absorb at least 100,000 graduate engineers in the next 5 to 10 years, I guarantee you. But are we ready in the academic world to create this 100,000 graduate engineers on these technology worlds and also the applications of these technologies to the real world application? It could be as basic mechatronics, pneumatics, hydraulics, electronics, CAD, CAM, CNC, very famous sensorics, controllers, robotics, and other IT related and communication related technologies. Or we focus on this control engineering, BTech control engineering should be the major focus of all our engineering and technology institutions, followed by partially automated systems and fully automated systems must be taught not only in postgraduate but also in undergraduate in the 4th year. All this requires, my dear friends, so far we've been talking about the technology know-how, multidisciplinary, general knowledge and specialized knowledge about manufacturing activities are here to stay, and know-how about machine tools, equipments and whatnot is required by all the functionalities. Perhaps not just the civil engineering can be exempted. and metallurgy to some extent, but even there they are coming into the convergence. But apart from that, the knowledge on internet enabled information technologies and internet enabled communication technologies, what we all call as ICT basis of skills, and finally the ability to work with the data. Yeah, this is a research done by Roland Berger. This slide I honorably thank Roland Berger. I am borrowing from them, and these are the kind of skills. The last but not the least is the personality behavioral related skills of ability to solve problems, ability to work with the team, and so on and so forth. These four basket of skills are going to be, must be taught, will be required by the industry. And I talked about those 10 domains which are waiting for such fantastic engineers who have the ICT skills, ability to work with data, technology know-how, and personality related skills. And that is the kind of jobs that we have designed on the behalf of Capital Goods Skill Council, on behalf of Samarth Udyog. Around 30 job roles have been designed by me, of which I just illustrated 10 job roles here. Factory automation engineer, digital manufacturing engineer, smart mechatronics engineer, predictive maintenance engineer, digital quality engineer, digital design and PLM engineer, data analytics, additive manufacturing, cyber security, augmented reality, and so on and so forth. And there are people are now fighting with each other. Who will create the job curriculum? Who will create the content and curriculum? Who will create the training programs? And the sooner we move in very fast on this, those 100,000 jobs will be really placed in the next 5 to 10 years. Disciplinary approach I talked about already is a combination of mechanical, electrical, and instrumentation, all leading to the mechatronics kind of a function. And the future automation engineers cannot be just a specialization of any one core sector, core function, but a combination of such three things will make them more employable. So I hope our third year and fourth year, we focus on multidisciplinary curriculum. I hope my university friends and all those UGC and other friends who are listening to me, AICTU and other people, come out of the new education policy debate anymore and talk about multidisciplinary functions in the third year and fourth year, definitely. Debate on the new education policy. And therefore, very, very important, from the multidisciplinary emerges the multi-skill approach. Even a CNC programmer and a CNC operator and a CNC maintenance function can be merged into one person. He will get a 40,000 rupees salary even when he joins the company. We have proved it in Makino, India, where a CNC person is trained on operation, programming, and maintenance. And at the end of 1 year after diploma, not even graduate engineers, he is eligible for a 40,000 rupees salary, either inside Makino or even elsewhere in the world. I am not talking about only India. Anywhere globally, we are now placed. And last but not the least, I want to talk about a summary of the personality skills and a summary of best practices, which are not only engineering, my dear friends, but engineering plus manufacturing excellence in the form of 5S. My good friend mentioned about it already. 5S, quality circles, Kaizen, lean, just in time, TQM, TPM, Six Sigma, visual management. Why no college is teaching this except little peripheral? One module is taught in the industrial engineering curriculum in some of my colleges like RV College. Other than that, in the undergraduate education, almost close to zero of these topics, which are extremely important for the employability and the process of selection for the individuals. It is too little in the colleges. Now I know a lot of third party are entering into colleges and making good money. Communication skills, working in teams, problem solving skills, collaborative teamwork, customer orientation, improvement mindset, systems thinking, and it's a big list. There are at least 20 to 30 soft skill training which is possible. There are very good training companies, and sadly, alas, when the student comes out of the fourth year from the college or fifth year as the case may be, even in my case, when I came out of NIT Trichy, I lacked both the left side skills, personality skills, and I also lacked the right side skills, the best practices skills in 1979. The same state of affairs even till today. So for 40 years, we have not learned what the industry requires. And finally, as my good friend Mrs. Moshini Kelkar mentioned, the experiential learning program and the Swiss-German model dual track training, what she alluded to as a sandwich course in VJTA in Bombay. VJTA model exploded across the country. Fantastic example given by Ms. Kelkar, and she is a living example of a first-time entrepreneur who is now doing that in her own company, on ensuring the students get industrial visits, projects and internships, etc. for every semester and for every course. First year, 2 internships, second year 2 internships, third year 2 internships, and fourth year is ready for a project at the end of last 6 months. And this is also enunciated in our Bachelor of Vocational Education policy, recently introduced by MSDE, and that is also a good model to be adopted for our BTech and MTech and various things, where the internship doesn't happen only at the end of fourth year, but please continue to have it throughout the thing. It is a kind of a sandwich course, but if you can make a credit and evaluation for this, it is very, very useful for the student and for the industry. They become employable not at 15,000 rupees, sir, but 40,000 rupees, I guarantee you, when they come out to this experiential learning concept with the hands-on as well as theory throughout their 4 to 5 years curriculum. And with that note, I thank you very much for giving me this opportunity, and I hope you enjoyed my talk. Thank you very much, sir.
Thank you, sir, for putting some light on advanced manufacturing skills, smart manufacturing, booming industrial technologies, future job roles. I believe it was a useful section for many. Thank you, sir. Now the forum will be kept open for interaction section. I kindly request all the participants to actively join the discussion. I would like to call upon Sri Narendra Reddy to come forward to moderate this session.
Good afternoon, and I welcome all the speakers and the participants for the interactive session. Before we get into the interactive session, to trigger the audience, would like to show the opinion poll what we conducted for this manufacturing training summit. We have conducted this survey, and about 250 responses we got, out of which 80% are from academia, 20% from industries, and 10% from research institutes. Maybe you can look at the statistics here for each question. I just quickly go through this statistics. The first one is on can we implement this skill-based education for the students? Can we use technology for learning, a mixed pedagogy of teaching involving simulation and hands-on learning? Can academic institutes focus on building strong relationship with industries and career advisors? Should academic institutes adopt do-it-yourself teaching methodologies? Can we have skill development programs for the unemployed engineering graduates? Yeah. Will industry academia collaborations leads to development of easily adaptable learning models? Can industry experts or scientists hold part-time positions in academic sectors, which enables a right blend of theory and practice? Should academic institutes focus on establishing COEs to impart quality training using subject experts in relevant fields from their alumni? I think most of the responses were positive. I mean, they are feasible and it can be implementable in academic institutes. Now I'll be going upon some of the comments which we have received from various people from research, industries, and academia. The first question is, we asked them to comment, what are the challenges academic institutes are facing in making a skilled manpower? Now, I'll be requesting all the participants to be very, have a live interaction with the experts from academia, industries and research organizations. I think we have deliberate lectures from the morning on various, all these aspects. But I'll be trying to start the discussion with the challenges what academic institutes are facing with respect to skilled manpower. I just highlighted here the curriculum gap between academia and industry demands. And many people also mentioned that they are facing some challenges because of this administrative works and the management works what given by the colleges. And many people mentioned that a lack of resources in terms of industrial exposure, knowledge trainers or lectures, not passionate people, and old conventional absolute syllabi, lack of laboratories, poor industry interactions, and there is a huge gap between what is required by the industries and what they have acquired in the academic institutes. Now the forum is open for the discussion regarding this question. I'll be requesting participants, you can please highlight your concerns to the speakers. Speakers are there to listen your queries and give the valuable input from their end.
You may raise your hands so that we will refer to you.
We request participants to raise their hands and ask the question.
Good morning,
They-
sir. Myself, Devani. I am assistant professor in Delhi Skill and Entrepreneurship University from Delhi. Sir, my question is that is there any training institute which provide manufacturing skills, etc., for diploma mechanical students at free of cost? Are there any institute, training institutes, sir?
For diploma holders, there are tool rooms under Ministry of Micro and Small MSME. These tool rooms are offering a post-diploma courses. In fact, these courses, majority of the tool room post-diploma courses are free. In fact, it's a practice-based learning, and they will also give some stipend. But otherwise, yes, there are several other training establishments. They offer the paid training, including CMTI.
Sir, during the diploma, they cannot attend these courses. Is it so, sir?
No, these
Only
are all
after
post-diploma.
diploma.
Yeah, after diploma.
Hello.
Sir, sir,
Hello.
summer courses,
Apart
winter
from that,
vacation courses like that.
apart from this, after a diploma, there is a apprentice boards are there. So apprentice boards are also offering a diploma train. These are like 1 year training programs with stipend of 8,000 rupees. CMTI takes 20 such diploma holders annually.
Okay, sir. Thank you very much, sir.
Good afternoon, sir. My name is Subramani from APS Polytechnic, Mechanical Department lecturer from Bangalore. So my issue is that relating to the polytechnic students, sir, since our polytechnic is located in the Bangalore rural area, so the common problems the facing of the students, the majorly in the rural belt area is that especially polytechnic students, the communication problem and the lack of basic knowledge in their primary school level. In order to cope up this, we have to be help like your central manufacturing institutes or industry side to set up their, at least to provide the trainings to these rural candidates apart from our academic activities. So by setting their excellence of center or internship programs. So like that, they want to sponsor the programs to rural institutes, so that we can also enable to guide the students to get industrial exposure before going to getting to job in industries. So it may be if you collaborate with the institutes, so that we can provide any excellence of center to our polytechnic students, sir.
Yeah, thanks for your query. Godrej sir, please go ahead, sir.
I'm going to be very direct in answering this question. I heard it that you get students who are not good enough to come to and learn a diploma qualification. In fact, that's the point that I had mentioned earlier. At least at your end, do not let such good students pass out of the institute. I think it's important. Screening exercise is important. That said, I think communication skills, I don't think we should bother at all. As long as the person has keen sense of, is curious, has a keen sense of intellect, can converse and express his thoughts in his mother tongue, I think that should be fine. I think that's the basic, and there should be a keenness to learn and implement and do it yourself. Those skills are more important. I would not bother about communication skills in English or whatever, none at all. Of course, the course curriculum, if it is not in the mother tongue, probably there will be challenges, but I think those challenges are easier to manage. It's important that person who pursues whatever he is doing is keenly interested, and he has not been put there because his friends have joined or his parents wants him to do, or and then he thinks somebody else who has been equally equal to him has.
Hello?
I think each one of us have a responsibility in that aspect. And to the earlier question, I think once again looking for free training, I think it's I think if we should look for training or we look for opportunity to work and learn in an industry, that itself is free training. If even if one gets the opportunity during diploma to work in industry as project trainees, or as Mrs. Kirkar earlier mentioned, work on small projects, get immersed in the industry, understand that those boundary conditions, and create, I think those learnings, and they would be free. I mean, I don't mind I mean, companies wouldn't even mind paying them a stipend. Those trainings are free, but I think the desire to learn, learn by yourself must be from the students. That cannot be sponsored.
Thank you, sir.
Hello, sir. Good afternoon.
Hello.
Good afternoon, sir. Go ahead, sir.
Myself, Dr. Lingesh. I'm a faculty member from Bengaluru Institute of Technology, Bangalore. So I would like to thank each one of you for your knowledge or the speech about the manufacturing and the opportunities for the students from the manufacturing sector. My question is so how to connect the academics and the industry together. So though I speak to some of the CASIA, which are situated in Bangalore, they people say that yes, we can able to made some curriculum which will be suited to the academic industries, but I am finding very difficulty how to make these two connect together so that we can produce the engineers which are ready for the industry.
Yeah, thank you, sir. Professor Ravi, sir, you can take up the questions.
First of all, a lot of nice comments and suggestions coming on the chat box. I think we could all look at that. Also, absolutely great points from my co-panelists. I have made copious notes. I think we should have separate one-off meeting just to look at what we could do together also. But if you summarize all the questions and comments into two groups, okay? For example, questions were like, if we have to take the products, research into products, whose responsibility is it? Is it academic responsibility or industry responsibility? I'm just reframing some of the comments into questions. Someone talked about CSR is there, but how about CAR? But I would say, why not about ACR? And I'll talk about that in a minute, okay? Also about innovation culture and academics. Where should the thing stop? Now, is it TRL 3 or 4 or go all the way? That is one bunch of questions. To which my single point answer is that it is academics who should take the first step. I think academics are becoming, they are blaming industry for many things, which I don't agree with personally. Although I represent academics, I think academics have the freedom and maybe the responsibility to take the first step. You go to industry, you find out what they're doing, you update your syllabus to make it industry level, you try to walk the path and create products which can be easily replicated. That is my single answer to that. The second thing is that bunch of questions was that, for example, how do you get respect for manufacturing? How do you make the remuneration for manufacturing? Like manufacturing versus IT is always a great competition, right? And also many times people talk about even surveys, which CMTI group put together. All questions where obvious answers was yes, of course it can be done, but who is responsible for doing that? My answer to that in one word would be, if you look at, let's say, take an example like Elon Musk. I mean, Vishweshwarya in our previous generation from India. But if you look at Elon Musk today, do you think he has respect among society generally? Do you think he's making enough money? I mean, there's no question or answer to this, right? I mean, big yes to both the questions. So I think the trick is that if you bring in IT into manufacturing, and IoT, Industrial 4.0, is the buzzword, but it's not a buzzword. If you seriously put all the things which I think Chandramouli sir has put together, beautiful sectors emerging and the skill set which has to be done, I think, but again, the responsibility has to come academics first. We have to go out of our comfort zones. Let's talk to industry properly, create those new content, whatever. And finally, my last word here would be that the game changer in the whole thing, what is the starting point? What is the first step which will trigger everything else? My answer to that is we have to create a whole generation, maybe 100 highly empowered, highly capable, highly committed manufacturing teachers across the country. In every institute, we should have at least one or two. I think that will roll out a whole generation of students who are far more interested, motivated, and also capable in manufacturing, IT-based manufacturing. Okay, that's my few words. But in a sense, I have answered all future questions also for as I'm concerned.
Okay, so I want to make 3 points. Point number one is, and it's a little bit, it's not necessarily responding to the question that are being asked, but also perhaps giving my reaction to some of the points that have been mentioned by the speakers. First is that I would like to actually start with a positive note that India in the last 2000 years, okay, for 90% of the time has been the richest in the world. It's only the last couple of 100 years that we have not been among the richest. And that's largely, and I think there is clear hard evidence, is due to the British. During 1700, India's GDP share of the world's GDP was 24.4%, which is equivalent to the world's the share of GDP of the entire Europe. When the British left, our world share of the GDP was 3.9%. Okay, and there was an equivalent rise in the GDP of the UK. In the next 30 years or so, India's GDP growth was around that 3.9% level. There was a little spike when Nehru took over. It went to 7% and then went down to 4% until the market was opened up, and that's when things have started picking up. So that's the growth story of India in the last 2000 years. Now, so clearly, if things can go, if things are so good at one point of time and things have gone bad, it can also go better. Okay. So we don't have to get too worried about the India's current situation. It has done dramatic progress given the size of the country, and it can do better. The question is, what can be done in the short term and what can be done in the long term. The second point is that it is important for the academia to have its freedom to work on esoteric problems. Okay, about a few hundred years ago, a bunch of mathematicians in Europe were looking at whether you can cross 7 bridges of a place called Königsberg once and be able to come back to the original point. Okay, you might call that an esoteric problem, but the mathematicians worked on that, and there was a guy called Leonhard Euler who was managed to solve that problem. And that was the precursor to what we know as graph theory today. And it is because of graph theory that we are able to today communicate with each other, because all mobile phones, all mobile devices use graph theory. And therefore, just because the problem is not right now relevant, because some industry are incapable of seeing it, doesn't make it irrelevant. Please allow academia to continue to work on esoteric problems. But that doesn't mean that we should not also work on non-esoteric problems. In other words, problems of today. Some problems are of today, some problems are for the future, some problems are forever. We must work on all of them. And it is up to the passion of the academic to decide whether they want to work on one or the other. We must, as an academia, have the platform that allows support for any of those academics. Professor Ravi and I are passionate about implementation. We should work on implementation. There may be others who are passionate about solving problems, mathematical theories. Let them solve mathematical theories. Most of the things that industry uses are developed by academia. 99% of the knowledge that academia industry uses were at one point of time or the other developed as esoteric problems. We talk about Newton. Newton didn't work in an industry. He did not go to industry to figure out what problems were there. He was interested in seeing whether apples are falling and why they are falling. And they became very important problems for the world. Okay, so let academia have its freedom, as industry should have its freedom to make money and create growth and so on and so forth, right? The question is, who is going to bridge it? There are multiple solutions. Again, I think we should put our designer hat on and say, what are the possible ways? It may be that academia takes the first step. It may be that industry takes the first step. It may be that there are bridge organizations like CMTI or Fraunhofer that takes the step, maybe Catapult. Let it be open, maybe all of them. I think we should create multiple possibilities. Let which one really works out to win. That's what we do in design. The third point is the following, that we also need to see what is it that industry offers to an engineer today. He gets trained, all very excited and worked up, that I'm going to do this great innovation when I go to industry. And then we go to industry and we find that there is nothing interesting or challenging. So what are the kind of jobs that are there in industry? I think it's important for the industry to also educate the students to say, look, most of your work is going to be mundane. The point that I'm trying to make is that academia is not simply a servant to industry. Academia is there to teach students the knowledge that currently exists and teach students how to create new knowledge. That's where the responsibility of academia ends. And academia must continue to have that freedom. They are not a kind of pipeline for their students to go and join some industries. I very strongly disagree, and that freedom must be maintained by academia. Thank you.
So thanks for the explanation, sir. I'll be requesting participants to be.
I think in the chat box, let us go with the chat box, some of the suggestions There is a proposal, like I propose a concept called CAR, Corporate Academia Responsibility, on similar line of CSR.
Yeah, I referred to it partially. I forgot to expand on that. I was saying that of course it is welcome, and I think we are hearing about it a lot. I was trying to say jokingly that when we also talk about ACR, which is academic responsibility to spend some time in corporate. And I think that has been Mohanji and many others have also said that. I think academics are not spending enough time in industry. And Amresh and me, of course, both, although we are examples of implementation part of it or creating success stories part of it, I think Amresh kind of came across in a different way. I know him personally, what he means from the bottom of his heart. But I think the point that we also both recognize and we both practice also is that most academics pick the problems to work on for research by sitting in their offices, and we both feel that they should go. I mean, Newton would not have invented if the apple had not fallen, right? If he had not gotten out of his office and sat in a garden and the apple had not fallen, he would have never thought about it. So it's very important for academics to actually go in the real world. He may not solve that problem, but it may trigger a thought about what is a generic problem to solve which can be applied to that in other industries. So I think academics spending a lot of time in industry, which is academic, you can say corporate responsibility is what I meant there, which is spending enough time in and with corporates. I think it's very good for research also, and I'm sure Amresh also knows that in the nuanced way. But freedom, I also equally agree with him that academics should not be weighed down by responsibility that they are the ones who should bring solve today's problems. We always are good at, and we should retain that freedom to take a step back and look at the big picture. I think that's what he meant.
Just note, I would like to add to both Dr. Amaresh's point and Dr. Ravi's point, excellent points. The two domains called academia and industry require an interface. The interface is what is going to bridge the gap. The gap is not a lacuna or a handicap, but the gap is intentional. Pure research, pure maths, pure physics are very, very important. The Newton's example is well taken, sir. But then there is an application requirement of an industry or even research field. So I think the concept of finishing schools, the training partnerships being recommended by NSDC, MSDE, the CMTIs of the world, yeah, that will bridge the gap between the pure academia and the so-called pure industry, if I may like. And therefore, this bridging schools are now the way of the world. But 70 years we lost in not doing the bridging the way Europe did it. 3 days of shop floor, 2 days of academia. 3 days of shop floor, 2 days of academia. 1940s, 1930s onwards, bang, 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 Switzerland, Germany. And there, even a diploma holder becomes a managing director of company in which I worked recently. All the MDs of the 10 divisions of my company were diploma holders, DIP engineering, and then they are doctorates. They can even go to university and do a PhD. So I think industry people going back to university is very famous in Germany. I think that there is nothing wrong with both the worlds. Let us not be frustrated by the academic world. They are producing the Newtons of the future. Let us not be frustrated with the industry world who are concentrating on delivering in 22 weeks or 22 days, as our colleague mentioned. But the bridging is being done by IMTMA, CMTI, Samarth Udyog centers. In a very frantic manner, we need to do that because we have to catch up with the 70 years of lost opportunity in this country. Thank you, sir.
So the lost opportunity is for 270 years, to be exact.
5,000 years, you may say. I don't know.
No. Until 1700, we seem to have been okay, and then we started falling behind.
Coming from Bengal, I can understand the passion on this, but I know 17th century industry 1.0 is the reason for all these troubles. I agree with you, sir. But let us solve it with 4.0 at least. Thank you, sir.
Yeah. Can I say something here? Whatever problems we talked, we don't have to invent a model. It is already there.
Yes.
Of sandwich course. Whatever we said, it can be addressed if a sandwich course is adopted. So centrally, if it is deployed, and the format and the model of sandwich course is already known. Nothing is unknown. Whatever we said, having better connect with the industry and all that, it can be achieved by just adopting a sandwich course.
What we now call as experiential learning in the new education policy is old wine in new bottle called the AGTA sandwich course.
No, sir, concluding
And we
now.
try to call it as experiential learning for want of a new coinage we are doing. I had in the text box for the 130 people who participated and those who registered, I typed out around 30 job roles which are emerging very fast. The YouTube learning is available free of cost. Mrs. Devyani from Delhi and all others, please note the free of cost or maximum 1,000 rupees. I think that today's students who are buying from Zomato and Swiggy for 1,000 rupees in 2 minutes they buy idli dosa. Please attend the NSDC, MSD courses which are only 1,000 rupees classroom training, excellent training program. CMTI, excellent training program. Yeah, all the Samarth Udyog centers, Indian Institute of Science, excellent training programs. Not at all expensive. Go for online program until Omicron is out of us. Thank you.
Yeah, I think we address all the issues. One issue is raised by Akshay Trivedi from IIT Roorkee. Is a suggestion like a lot of designs designed by students, but there is no manufacturing support to realize their design into a concept. Yes, this is a really problem. We institute like CMTI, so there is a platform, technology platform our ministry has floated. There are one from CMTI that we call Dristi, another from KITE, IIT Madras, then ARI Technovas, ICAT, there is a ASPE, and HMT, and then BHL. There are total 6 platforms are there. There is a mechanism to realize the concept to product through this technology platform. Maybe you can register there, or you can ask your students to register there. There is a support also to realize concept to kind of prototype first conceptual models. So now we are already time overrun. I think I will end the interaction session at this level. As all speakers and all some of our our participant expressed, there was a suggestion, so that means there should be a dedicated live interaction should be there. CMTI will definitely look forward to that, because here also we have an interest to design our training programs as required by industry, and at the same time imparting practical base without compromising on theoretical understanding. We will definitely look for another event to discuss. And yes, there was is a 2.5 hours virtual seminar, but we wanted to have the physical seminar that would make more impact than the virtual seminar. Particularly, there are so many aspects can be discussed in the open forum, and there are a few other things which may not be even good to deliberate in the open. Each individual has different opinions. But end of the day, we all know HR development is our collective responsibility of all these 4 elements which I mentioned: individuals, in the employer, institutes, then the government. I'm sure there are many things is happening parallelly, and only thing is we need to connect these dots. With this, we will end this session. Formally,
Shukla sir has something to say.
yes, sir, Shuklaji sir, you have anything?
Yeah, I just wanted 30 seconds so that we could end this note on a smiling.
Right, sir.
If you don't mind, give me sharing rights.
Yes, sir, is given.
So tell me once you see my screen. Are you able to see?
It's coming up.
Yes, sir.
It's coming up, sir. Once. Yes.
Yes, sir. Okay, so this is a story about a baby camel and a mother camel. So baby camel, I mean, the dialogues are straightforward. Mother, may I ask you some questions? Say, sure, my son. Is there anything bothering you? Why do camels have humps? Well, son, we are desert animals. We need humps to store water, and we are known to survive without water. Okay, then why are our legs long and our feet rounded? Son, obviously they are meant for walking in the desert better than anybody does. Okay, then why are our eyelashes long? Sometimes it bothers my sight. My son, those thick, long eyelashes are your protective cover. They help you protect your eyes from desert and sand and wind. Okay, so I see. So hump is to store water when we are in the desert. The legs are for walking through the desert, and these eyelashes protect my eyes from the desert, right? She said, yes. Just one more question. If that is the case, what are we doing in the zoo? And I think this is the question that I think our, my friends in academia should, pose to their students, that skills, knowledge, abilities, and experience that they are acquiring in engineering colleges are useful only if they're right places, and, we therefore urge engineers to do engineering. Thank you for giving this. Thank you for indulging me in this.
Thank you, sir. Thank you.
Very nice way of ending, sir. Shukla-ji.
Okay. Thank you everyone for your gracious participation. We have arrived to the concluding section of this event. I request Shri Arun Kumar JG, Chairman of Azadi Ka Amrit Mahotsav Committee, CMTI, to deliver the concluding remarks and vote of thanks.
Yeah, good afternoon, sir. First and foremost, I would like to express my appreciation to our eminent speakers, panelists for their valuable contribution to our manufacturing training summit. On the gaps in the skill sets of engineering students and the role of teachers and other stakeholders in imparting the required skill sets on this occasion of Ministry of Heavy Industries week of celebrating Azadi Ka Amrit Mahotsav. Thank you for all our speakers, sir. First, I extend my gratitude to Ministry of Heavy Industries for giving us this opportunity for celebrating Azadi Ka Amrit Mahotsav in CMTI as part of this week-long celebration. I would like to thank our esteemed speakers from academia, research and industry for joining us today. Thank you all, sir. I thank our director, Dr. Naga Hanumaya, for being the key person in organizing this event at CMTI. Thank you, sir. I would like to also thank all the active participants who have contributed towards the successful interactive session. Finally, I would like to thank everyone who have worked for the success of this event. Thank you, one and all, sir.
Sir, I request all the speakers to switch on their video. We'll just take the screenshot. Thank you, sir. Thanks for your time and comments. We look forward to one more interactions with maybe physical interactions. So, thank you, sir.
Thank you, everyone.
Thank you so much, Dr. Hanumantaya. Thank you so much, all my co-panelists.
Great meeting.
Thank you all. Have a nice lunch.
Thanks a lot.
Bye-bye.